We have been doing this last bit a little bit for a big chunk of the year in our warm-ups. Solving absolute value equations algebraically. To solve an absolute value, first isolate the absolute value expression on one side of the equation the same way you isolate a variable. Alright? Then use the rule. If f of x is a, then set it equal to a and negative a. Notice the use of a disjunction here. Right? That means an or. You cannot know from the original expectations whether the expression inside an absolute value is positive or negative, so you must work through both possibilities. So here we go. Right? So if I'm going to solve, we're going to rewrite this over here. 3 times 4x minus 5. You know what? They're doing it right here, aren't they? They added 2. So if I add 2 and I add 2, that 2 turns that in 19 into 21. Then we divide by 3. 21 turns into 7. And look, I've solved for the absolute value. That means I set it up equal to 7 and negative 7. Right? Add 5 to both sides in both cases, and we get 7 plus 5 is 12. Negative 7 plus 5 is negative 2. And then we divide by 12, and we get x is 3, which we'll mark right here. And x is negative 1/2, which we'll mark right there, and we're done. Alright, let's try one more, right down. We want to try a couple more actually. So I want to solve by multiplying both sides by 2, so times 2 and times 2. This gives me the absolute value of x plus 2 equals 20, and then we set it up twice. We go x plus 2 equals 20, and we'll say, let's put it over here maybe. X plus 2 equals negative 20. If we subtract 2 over here, we get x equals 18, which I will mark. Ooh, this goes by 4, so 18 is right there. Subtract 2, x equals negative 22. And look, I put that as a negative 18, so let's fix that. Let's put 18 up here, and negative 22 is also in the middle. You know, they need to give some better scales for us. Same thing here. So we're going to solve for this. So we start by subtracting 5. And hopefully it's familiar, because we've been doing something like this all year. I've shown you a number of absolute value equations when we're doing warm-ups. And our goal is to solve for the absolute value. And now we got 3x minus 6 equals 2. And that's the absolute value. Remember, I can either put a positive or negative inside that symbol to get myself a positive 2. So I'm going to go 3x minus 6 equals the positive 2. And 3x minus 6 equals a negative 2. If I add 6 here, I get 3x equals 8. Divide by 3x equals 8/3, which will... Let's see, what does this go by? 2/3? So that's 4/3, 6/3, 8/3 is right there. Add 8 here, or sorry, add 6 here. 3x equals 4. Divide by 3x equals 4/3, which we have right here, 4/3. Alright, we got a couple more to do. And I think we're on the last page already, which is kind of nice. What page was this? We're here. Alright. So there are situations where absolute values don't have any answers. And you'll like this one, right? So here I go. Let's solve this guy right here. I'm gonna write it out here. 3/5 times 2x minus 4 minus 3 equals negative 3. If I add 3, I get 3/5 times 2x minus 4 equals 0. And I'm just doing it out here instead of these spots over here. Multiply by 5/3. It allows me to show more steps because I got more room. This gives me the absolute value of 2x minus 4 equals 0. So in a situation like this, right, I normally get rid of the absolute value and I replace 0 with positive or negative 0. But there is no negative 0. So, actually, there's no positive 0. It's a neutral number. So all I do is I write it once. And then I solve that one spot. So I add 4. 2x equals 4. Divide by 2. X equals 2, which I'll also write over here. Alright. So, here's the rules. If you solve for absolute value and you get a negative number like this, there are no solutions, because there's no way an absolute value can equal a negative number. No solutions. If you solve and you get a 0 like this, there's one solution. And those are the situations where absolute value doesn't have two solutions. Alright? Let's go here. If we subtract 7, we get 3 times 1/2 x plus 5 equals -2. We divide by 3, we get the absolute value of 1/2 x plus 5 equals -2/3, and we're happy, right? That's negative. We say no solution. Nothing can make this absolute value equal to a negative number. So this is probably going to be a 0. Subtract 7, 9 times 4/3 x minus 2 equals 0. Divide by 9. We get the absolute value of 4/3 x minus 2 equals 0. You know what? It's 0. Can't do positive or negative. So we just say 4/3 x minus 2 equals 0. We add 2. 4/3 x equals 2. And we multiply by 3/4. And we got x, because these guys cancel off, equals cross 3/2. Done. Alright, so there's a few questions here. Let's just talk through them. This first one says, why is it important to solve both equations in the disjunction arising from an absolute value? Why not just pick one and solve it, knowing the solution for the variable will work when plugged back into the equation? Well, because both solutions may have real world meaning, right? Discuss how the range of an absolute value function differs from the range of a linear function. Well, linear functions often have outputs infinite, both positive and negative. For instance, that goes up and down forever. Absolute value, max out, or have a minimum value. So if I was right here, right, that would have a max. If I look like this, that would have a min. Alright, so we're going to stop there, and that's the end of our videos.